Hello. Good morning, everyone. I am wondering if you are able to hear me. Thank you. Thank you for letting me know. Please go ahead. Do you have a question, Deborah? I will just wait one more minute before we begin. Good morning, everyone. Thank you so much for joining me this morning as we talk about the wonderful world of plants. So we'll talk today about three of the symbols of this season: the bunny, the egg, and the tulip. Each of these symbols is associated with renewal, rebirth, rejuvenation, and of course, the spring season. So I have a chat window open and I have the Q&A window open. And so I will do my best to answer questions whenever you put them up. But if I do not reply right away, please give me a little bit of time and I will get to all the questions by the end. So I'm happy to answer as many questions as you'd like to ask after things are done, but you're also absolutely free to just ask questions throughout the presentation. So what I'd like to do is give you a little bit of a different perspective to some of these symbols of Easter. And perhaps we'll start with the bunny. So when we go outside, we go out perhaps into the grasslands. We see the beautiful landscape, the green from the grass, and we think of sort of the openness and the beauty of nature. What does a bunny see? A bunny might see something like this. It sees a landscape of food. It sees what we might think of as a salad bar. There's lots of leaves everywhere that they can eat. There's lots of seeds all over the place produced by the plants. And it is an absolute oasis of plenty. So what happens when this gets out of control? What we know is that rabbits were introduced into Australia by European settlers who wanted a little piece of home and brought just a handful of rabbits. And without natural predators, without plants that were adapted to being eaten by rabbits, the number of rabbits went bananas. And literally, the landscapes were covered with rabbits. So if you think about it from the plant's perspective, one of the things that plants are genuinely not famous for is moving. They can't really move. They're kind of stuck in one place. So when rabbits and other things that eat plants, which we call herbivores, their plants are faced with these herbivores, what can they do? And this is a very interesting area of botanical research, of looking at what we call plant defenses. So what are these plant defenses? And something I'd like to help you do maybe is that as you go out into the outdoors this summer, maybe you'll start to notice that a lot of the things that we see on plants have to do with how they defend themselves against other organisms. So the most obvious plant defense, I think, for myself and many others, are things like thorns. So thorns are structures on plants. They can be found on the stem. They can be found on the leaves that deter things from eating the plant just by poking at them. And so you can see that they're quite sharp. Some of them can be coated with chemicals, but essentially it is making it very inconvenient to eat a plant. But one of the things that you might also notice when you start thinking about defenses is that things like thorns are probably good for specific kinds of herbivores. And if you were a little insect, these thorns would just be nothing but tall outcroppings as you're walking along the surface of a stem or a leaf, because they're too big to be of any use to let's say, most insect herbivores. Another thing you'll probably notice when you go look at your house plants, or maybe at a grocery store, there are some plants. You'll notice that plants sometimes are very waxy and shiny, and they feel very tough and thick. And a lot of times, this is a very basic defense where the physical presence of wax deters things from enjoying eating the leaves. And waxes, like all these defenses, often have multiple uses for the plants. The wax is very useful for keeping the plant from getting dehydrated, but it is also a physical barrier to being consumed. But one kind of defense that's actually very common that we may not notice is very similar to that of the thorns, and these are the trichomes. These are little hair-like projections that we find on leaves and stems of things. And for us, when you think about something like, if you've ever seen an African violet, it's velvety and soft to the touch. But if you look carefully, there's often some sort of carpet, almost like a shag carpet of these hairs called trichomes. The trichomes have many purposes, like we were talking about with a wax. They can be sort of a almost insulating layer to prevent or reduce heat exchange from the plant to the environment. But a very important role they have can be that of defense. And to our touch, they seem smooth because we are very big, the trichomes are very small, and so their effect would not deter us. However, when you look at insects on their scale, these hairs are incredibly important. And insects are the most important herbivores in terms of the amount of plants they eat in the world. So when you look at these trichomes in detail, and this is something you can do just by looking very carefully at a leaf, you'll see that they have a lot more structure than you might imagine upon first glance. And so what is actually a hook-like structure might feel very smooth to the human touch, but from the perspective of a visiting insect, it can be a deadly trap. And what's really interesting is how much diversity there is in these trichome structures when you look at them. A lot of the things that we have in the plant world are not so obvious if we don't look very carefully. But even a small magnifying glass can help us achieve this. Probably one of the more exciting forms of defense that plants employ to protect against other things eating the plants and thinking of them as a salad bar are the relationships they form with other organisms. So this is the famous relationship between the ant and the acacias that we're looking at here. The plant provides a home. If you look on the left-hand side, some of these horn-like structures are empty and become nesting sites for ants. It also provides rewards, if you look on the right-hand side, in the form of nectaries. So these are sugary treats for ants, as well as what are called Beltian bodies. If you look at the tips of the leaves, you see these leaflet-like structures that are energy-rich in lipids and proteins to help feed the ants. And the plants have co-evolved with the ants to provide shelter and food in exchange for the active defense of the ants. And so if a different insect lands on the plant, the ants will swarm to attack whatever herbivore might be visiting. And in fact, the ants can be so effective that they can deter anything from anything like small mammals because they're so intense in their defensive ability. So there are a lot of these relationships that if you look carefully, and you can see similar relationships even in our backyard here in Alberta, where you see ants and insects interacting. For example, the peonies in my gardens provide lots of nectar for ants, and the ants are very aggressive in preventing me from touching my peony flowers. But perhaps the most important form of plant defense overall is something that is largely invisible to our eyes, our unaided eyes. And that is that plants produce an incredible array of chemicals that are specific and very diverse in how they can defend a plant against herbivores. So this plant here is called the beech apple, and this manchineel is considered to be one of the most toxic plants in the world. You can see that in areas where the manchineel grows, there are often signs or X's painted on them to help people avoid eating or touching these plants. The touch of the plant can cause inflammation and blistering of the skin. Certainly eating the fruit can cause all sorts of irritation in the throat. And even when, as the sign suggests, there is rain, some of these chemicals can wash off and affect you, even as large as we are as human beings compared to most other animals. And the thing that I'd like to sort of help you hopefully appreciate is that plants are really incredible chemical factories. A lot of the things that we associate with taste, that when we drink tea, there's sort of a bitterness. When we eat celery, there's that strong celery taste. These are chemicals that are often associated with plants protecting themselves from consumption by other creatures. So what I hope you see when you go outside this summer and you look at the plants in your neighborhood, plants outside in the park, you'll start seeing what plants might be doing to protect themselves from all the organisms that are out there trying to eat them, just like they're feasting at a salad bar. So another thing that I hope you might take a look at when you go outside this summer is keep an eye out for eggs. Eggs of insects that are often found right on plants. And what you can see here in this series of photographs is that these eggs of plants, or eggs of insects on plants, are incredibly beautiful. Many of them have intricate structures that remind us of things like marbles and vases and other beautiful things. And what I want you to sort of keep an eye out for is just how different they look. Each insect produces an egg that looks a little bit different from the other eggs. To give you a sense, there's all sorts of different shapes and sizes. So if we look here, we can see in this panel, long elongated eggs to some that are much more decorated in their structure. In fact, if you look at the diversity of eggs carefully, so we're going to look at stick insect eggs here, you can see that this whole array here on the left-hand side is just like a museum of pottery. There's incredible detail, incredible color, different structures, and so forth. And these diverse set of eggs are produced by the insects you see on the right-hand side here, the stick and leaf insects that are famous for being cryptic and hiding in plain sight by their camouflage and disguise. So why does an insect lay its eggs on a plant? And this is a very important thing that parent insects do, is where they start the lives of their offspring. And so what we have on the right-hand side here is a life cycle of an insect that many of us are familiar with, the monarch butterfly. And so the adult butterfly lays an egg on the leaf of a milkweed plant, and specifically the milkweed plant. The milkweed plant is famous for producing all sorts of chemicals that are very toxic to most insects and organisms. However, the monarch butterfly caterpillar can consume the leaves of this plant and in fact sort of use the chemicals that are found inside the plant to protect itself from its predators because it becomes distasteful as it feeds on the milkweed. Well, what the parent butterfly has done is selected a location such that when the egg hatches, that its offspring are now laying on a bed of food. Just like the rabbit that was on a landscape of grass, we have a caterpillar that is able to just feed on everything that it is sitting on. And one of the interesting things about insects, particularly things like butterflies, is that they have a very, they're marked by stages of metamorphosis. And so the caterpillar, once it's fed enough and matures, it becomes a chrysalis, a pupa, and then from that, an adult emerges. And one of the things that you'd notice from this pattern is that the adults, which may feed on things like nectar, are feeding on something very different from the offspring. So they're not feeding and competing on the same source of food. And this is one of the reasons that insects are so successful, and there's so many different kinds of insects, and that one of the great patterns of diversity is that we understand that the number of plants, so plants being in the hundreds of thousands of different kinds of plants, is related to the incredible diversity of insects, which is thought to be in the tens of millions of species. Something that you might see in your backyard on the left-hand side is a ladybug. And if you look carefully on on the leaves or stems of different plants in your garden or just outside somewhere this summer, you'll find that you'll see these little yellow eggs. They're not all yellow eggs aren't ladybugs, but a lot of them will be the ladybird beetle here. And when they hatch, they're not actually consumers of the leaf matter. They become these larvae, if you look on the middle bottom here, and that larvae feeds upon all sorts of other little insects. It's a carnivorous larva. But the adult has located the eggs so that the larvae can be somewhere where there's lots of opportunity to feed. So keep an eye out for eggs. Last summer, I was trying to grow some beets, and I found that some of my beets were getting eaten. And so I looked carefully on the leaves, and to my amazement, every single beet leaf had exactly one little white egg right in the middle of the leaf. And so it's sort of, I was amazed that probably a butterfly larva, butterfly egg, sorry, was chosen to be placed exactly spaced out one leaf per egg. And well, that wasn't good for my beet crop, but I was amazed at how well the butterflies were able to take care of where their juveniles would feed. So last part of our story, our Easter story, is that of tulips. And tulips are plants that we'll see in our gardens, in gardens of people planting them in their neighborhoods throughout. If you go to Ottawa, there is a festival of tulips every spring based off of like 100,000 bulbs that the Dutch royal family still sends Canada every year, sort of in thanks for protecting Queen Juliana during the Second World War. And so there's an immense display of tulips that you can find throughout the Parliament grounds and near the canal in Ottawa. The tulip is a wonderful plant. It starts, if you will, as a bulb-like thing, very similar to an onion. If you want to plant tulips, you need to plant them about twice as deep as they are tall, because they need to be underground and protected from direct cold and so forth. And over the winter, they, like a lot of plants, they need a little bit of cold to let them know what season they are in. Because if you can imagine, most plants, they can't look outside, they're underground seeds or bulbs in this case. It's dark. They don't know what season it is, but the temperature tells them and gives them a sense of what season it is. And as it starts to warm up in spring, the starch, plants store their energy as starch, gets converted to sugars that help the plant grow. And we have a tulip flower very early in spring. But what's really important if you want to be a tulip farmer and grow the number of tulips you have is to let the leaves then continue to grow and photosynthesize after the flowering has taken place, so that it can form daughter bulbs that are underground. So it's not, in appearance, not that different from how garlic looks. And you can see that after the flowering takes place, the daughter bulbs start to form, which then you can split up if you're so motivated and increase the number of tulips you have. And of course, this means that whenever you see a large stretch of tulips, somebody has gone through a lot of work of planting these bulbs and spacing them out underground. The story I want to tell you about, though, is one of the most incredible stories in the history of the interaction between plants and humans, which is the story of tulip mania. This is a story where in the 1600s, tulips became so prized by the Dutch that there became an incredible economy and market for trading these tulips. At the height of the craze, a single tulip bulb, so like we just previously saw a whole basket of tulip bulbs, a single one of these bulbs here could be traded for a very fine house in Amsterdam. But let me step back for a second and just sort of tell you a little bit about the history. So tulips are plants that came from what we now know today as Turkey and parts of the Middle East, such as Iran. And they were brought to Europe in the 1500s. And of course, because they were transported such long distances, they were incredibly expensive and prized by gardeners, European gardeners. And it became sort of a fad where very wealthy people could show their wealth and display their wealth by having tulips in their gardens. But as people became good at growing and propagating these tulips, they became accessible to the rest of the people, and everybody wanted to have tulips. What was special was that there were certain varieties that were very unique, and you can see sort of in their incredible patterning here that they were both rare and special. And one of the reasons that there's so many, if you go to a museum, there's so many paintings of things like tulips from that period by really masterful artists that were contracted to paint these things, was that it was more affordable to get a masterwork painting than it was to buy an actual tulip bulb. So some of the incredible stories of the value of these tulips, it can be exemplified here with the Viceroy. This single bulb of this particular kind of variety of tulip was thought to have been traded, a single bulb, remember, for 12 sheep, 8 pigs, 4 oxen, 1,000 pounds of cheese, 8 tons of rye, 4 tons of wheat, a silver goblet, a suit, a bed, wine, barrels of beer, and butter. And so this gives you a sense that really people were speculating and really willing to trade real things for what was the most collectible thing of its time, the tulip. And the most famous of these is the Semper Augustus. And this tulip, beautiful with its red and white stripes, sold at the peak of the tulip craze for 10,000 guilders. And so the average person made around 150 guilders a year. And so this is 75 years' salary was traded for a single tulip bulb. And this is sort of an incredible thought that this could happen, but it is really an interesting story of how people like to collect certain things. But the real interesting part of this story is why some tulips have these banding patterns and these beautiful colors. It was not really understood at the time why these tulips had stripes when most tulips are solid in color. What was understood was that somehow it was reducing the size of the bulbs year after year. One of the reasons these precious tulips were rare was because they weren't very good at being tulips, and so they were less viable and hence lower in number. And the story here is that as we start to understand what is going on inside the plant, we understand that plants, like all organisms, have their own set of viruses. And this particular, the most common of these viruses that leads to this incredible banding is the tulip breaking virus. And it is a virus of plants that changes the sort of the patterning of the pigments called anthocyanins inside the perianth, or the petal-like structures of the flower. And the interesting story, I think, is that there's this very cute creature called an aphid that is probably one of the most important vectors of these things like viruses. And so the aphid here is an insect, and this is an adult aphid. And you can see that its mouth part or its stylet is like a syringe. And it goes around and it sticks its stylet right into the cuticle of a leaf, and it starts drinking sap. It doesn't actively drink, it sort of just connects to the vessels inside the plant, and it's like a IV. It just sort of drains through the insect, and it feeds on the sugars and the proteins that are found inside the plant. But as a byproduct, as the aphid moves from plant to plant, it has this, it can infect plants by moving from an infected plant to a non-infected plant. And this is, in fact, how the rare tulip breaking virus was spread around different tulip farms in the Netherlands. And so when you look at tulips this summer and this spring, I hope you sort of think about the incredible history of this plant. Think about its journey from being a plant that's found in Turkey, in Iran, to moving to Europe, to now commonly found in our parks and backyards in Edmonton. And I think that it sort of is I like thinking about tulip mania whenever I think about or see tulips. So the story of tulip mania ultimately had a somewhat sad ending, in that at some point people realized that they didn't want a tulip more than they wanted a house. And that sort of started a cascade, and sort of in 3 brief years, there was this incredible surge of interest in tulips and equally impressive decline in their interest. And maybe that was to be expected. Well, thank you for joining me in talking about some stories of how the symbols of Easter, the bunny, the tulip, and eggs relate to plants. I'll be doing another workshop on Victoria Day weekend, just to talk about some other things. Oops, I don't know if you lost the scene there. If you have any questions about plants, I'm going to stick around and I'm happy to answer them, but you're also welcome to email me. And there are other programs, such as free music programs for kids at MacEwan Continuing Education, that you can look at. If you just go to the sign up page here, there'll be more information about those things. So thank you very much. I will stop sharing the screen, and happy to take questions if you have any. Thanks, Shelley. Thanks, Martina. Yes, I will be, this session was recorded and it will be available, and you'll probably get a follow-up email from the office.